Today we're going to be doing Chapter 5, Section 5.5, Question 9, and it's a Ferris wheel question. So the first thing to do is to look at the question and see what information there is there. So first we can find the radius, which is 25 meters. We know that it's 1 meter above the ground. We know that one rotation is 24 seconds, and that the person at the beginning starts 26 meters above the ground. So with that information, we can fill out the formula. Y equals A sine or cos B x minus C plus D. So the first thing I like to do is just find each of the variables. So A, which is the amplitude, is going to be the radius in this. So A is 25. To find C, C is the phase shift, and since the person starts 26 meters and we're going to be using a sine graph, there's not going to be a phase shift, so we can just put a 0. The D is the vertical displacement, and to find that, you just have to think of how a normal sine graph would be. And a normal sine graph goes over the x-axis, and in this situation, we know that the person starts 26 meters above the ground, but the Ferris wheel itself is only 1 meter above the ground, so you can assume that the 26 meters here is the middle point, which is what the vertical displacement is. So that's going to be 26. And then to find the B is part of the period. So the period equals 2 pi over B, which we can solve to be 2 pi. And we know that one rotation, which is what which is the information we need to find the period, is 24 seconds. So we're going to do 2 pi over 24, which equals pi over 12. So now that we have this information, we can put all of that in to make this equation full. So 25 sine pi over b x plus 26. The next question is asking how high above the ground a person would be after 16 seconds with the Ferris wheel. And with that, you have to use your calculator and plug in the x value of 16, because like we found before, the x value is going to be the time. So when x equals 16, you find that the y value is 4.35 meters. And in this question, how many seconds on each rotation is the person above is 35 meters in the air. Again, you do is you would plug in another y value. First thing you do is plug in this equation as a y value, then plug in another y value of 35 meters, and then find the intercepts between when the graph first crosses that bar and then when it goes back below it, and find the difference between those. So in this situation, it would be 10.59 minus 1.406 approximately, which gives the answer of 9.18 seconds.